Welcome back, ladies and gentlemen. This is Mr. Smith, and this is a new unit. We're starting Unit 5. It has everything to do with geometry. Our first real dive into geometry. We're going to be dealing with a little bit of geometry in both Unit 5 and Unit 6. This one is more about angles, so Unit 5 is about angles. This lesson is 5.1, Angle Relationships. So this should be review here. If it's not, don't worry. That's why we go over this. A circle has how many degrees? If you said 360 degrees, you are correct. A right angle is 90 degrees. And that's what that little circle up above is of the 360 and the 90. That's a degree symbol. If you think of degrees Fahrenheit or degrees Celsius, that's what that symbol is right before the C or the F. In this case, for angles, we just put degree. We don't put C or F. A straight line has how many degrees? Well, if this is 90 degrees, we actually have 90 and then another 90. So this is 180 degrees here. And if you think of a circle, it actually has 1, 2, 3, and 4 90-degree angles all combined, and that gives you 360. Okay, this should all be review. Let's move on to the next set. We're going to talk about some rules here. This does get a little bit wordy in rule number 1. This is known as the complementary angle theorem. So this is the complementary angle theorem. Angles that combine to make a right angle add to 90 degrees. So in this case, we have x over here and y over here. X and y add together to give us 90 degrees. This is known as the complementary angle theorem. Our next rule that we're going to talk about is going to be very similar to the complementary angle theorem, except it's called the supplementary angle theorem. So this is the supplementary angle theorem. And in this case, we have x and y that add together, and they just add to 180 degrees instead of 90 degrees because it adds together and gives us a flat line. Our final rule is something that's a little less intuitive. It's called our opposite angle theorem. And what this means is that whatever's opposite of an x, like this, of two straight lines, so A and B will be the same. So A equals B. And the same can be said for C and D. Let me use blue for this. So if I have C and D over here, so C is equal to D, because they're opposite angles of an x intersection. Notice that it kind of looks like an X here. Got your cross here and then here. Later on, we'll be discussing this and calling this the X pattern. But for now, remember it as the opposite angle theorem. That's what it's called. Okay, next slide. We need to determine the angle and justify it. If we have 36 degrees right here and X over here, what do these two angles add up to? Well, it's not a flat line, it looks like a corner. So we know X and 36 are going to add to 90 degrees. If we take the 36 over, we can actually solve for X. You guys have done this. You did it in Unit 1, you did it in Unit 2 a little bit, and you should be able to solve for X now. So we have X equals 90, subtract, because 36 comes over, it becomes negative. So 90 subtract 36, and you get X equals 54 degrees. Done. Easy peasy. Oh, we have to justify it. What's the rule called? If I actually go back a slide, where's the one with my corner? It's rule number 1, complementary angle theorem. Okay, so for short, we'll put CAT, because the cat's in the corner. If that helps you remember, complementary angle theorem, CAT, cat in the corner. Next, we're going to look at example B. where we have x and 75 degrees. For some reason, my degree symbol got messed up. I have x plus 75. Well, if it equals a flat line, how many degrees are in a flat line? 180 degrees. So x plus 75 is going to equal 180. If I move the 75 over now, I'll get what x is equal to. X is equal to 180 subtract 75. So x equals 105 degrees. And which justification is this? Which rule did I use to solve that? Well, if I go back, it's not in a corner, so it's not cat. It is a straight line, so it's sat. Supplementary angle theorem. Sat on a straight line. Cat's in the corner, sat on the line. If that helps you remember, you can feel free to use that. So cat on the left, sat on the right. And let's move on to our next examples. We have 3 more examples coming up. Next example, determine the value of x. This looks tricky, but remember, if we're using our cat, because it's a corner here, it's just x is our first angle, right? Plus 2x, which is our second angle, and it's going to equal 90, right? We can solve this. We just collect like terms and solve for x. You guys have done this before. X plus 2x is just 3x equals 90. Okay, now we have to get rid of the 3. To get rid of the 3, we have to divide both sides by 3, and we'll get x equals 30. Done. Remember, cat's in the corner. Like the song, Cat in the Corner with Silver Spoons. There you go. So there we go. We have cat for this one. Let's move on to the next one after I embarrass myself with song references that you guys probably don't remember. Example 3, determine the value of x. For this, we have, well, it looks like an x pattern. If I go back a few slides, I should be able to find what we do with an x pattern. Okay, in an x pattern, the opposite angles are equal to each other. Okay, so that's our opposite angle theorem. So if we go back here, this angle is opposite to this angle here. That means that those two are going to equal each other. Let's start with that and work our way through it. So we have 5x minus 10 equals 3x plus 8. All right, just like we did before, we know how to do this. It looks tricky, but it's actually not that bad. We're just trying to determine the value of x, not the measure of the angle. So to solve for x, we start collecting like terms. Well, first, this has to go over here. It's going to become negative. We'll have 5x minus 3x, right? Because positive 3x becomes negative. Then I have to move this negative 10 over here. So I have positive 8 still. And then negative 10 goes over, becomes positive, so we add 10 to it. Now we just do our simple addition and subtraction. We end up with 5x minus 3x is 2x, and it equals 18. To get rid of the 2, we have to divide both sides by 2. X equals 9. Done. And the theorem that we used was opposite angle theorem, because it's on the opposite side. OAT for short, OAT. Let's move on to our final example. It has 2 parts to it. First part, determine the value of x. Well, this is a straight line. It kind of looks like a T. If it's a straight line, then that means that we need to use one of the rules. Rule number 2, supplementary angle theorem. They're going to add together to give us 180. Okay, so I need to add x minus 8 plus 2x minus 1, and that should equal 180. All right. First thing I'm going to do is I'm going to drop the brackets. Plus 2x minus 1 equals 180. I like to collect like terms. Remember, you could use different shapes for this if you have different colored pens. This works a lot nicer. I'm going to use circles for my x values here, and then I'll use, let's say, red boxes for the constants. Okay. X plus 2x is just 3x. Negative 8 minus 1 is just minus 9. Equals 180 is still over here. Well, now I actually have to take this and move it over here. And when I do that, that negative 9 becomes positive. And we are left with 3x on the left side and 189 on the right, because 180 plus 9 gives us 189. I jumped a step just to move things along a little bit quicker. Then we divide both sides by 3. Now this is a little tricky. If you have a calculator, you can do this. What's 189 divided by 3? You should get 63 degrees. So that's our x value. That's the first part. The second part is asking us to find the measure of angle ABC. And what that actually means, okay, I do have blue. So I'm going to show this. A, B, C is labeled here. So A to B, B to C. So it wants us to find this angle in here first. To do this, you just have x minus 8. So I'm going to write angle ABC is equal to x minus 8. Well, then you just sub in your x value, which is 63 minus 8, and that equals 55 degrees. All right, I'm going to grab a different color for this next one. Let's say green. And angle C, B, and D. So from C down to B, out to D here. So that's this angle over here in green. We have 2x minus 1. So this is going to equal 2x minus 1, which is just equal to 2 times 63 minus 1, which is 126 subtract 1, which is just finally 125 degrees. And that's it for that. That's both of those. Alternatively, because it's SAT, you could have found angle CBD by doing this. 180 subtract 55 equals your unknown angle, which would have been 125. Right? Because both the green and blue angle add together. So angle ABC and angle CBD add together to give you 180. So that's one way to solve for that. I forgot to write SAT up here as our justification. Okay, that should be enough for you guys to work through. It does seem a little bit weird at first, but it's mostly just patterns and algebra, and a lot of you guys did really well with algebra. So if you need to review that, just take a look over your notes. If you need help, make sure you ask questions, and that should be enough for you to do your homework. All right, all the best and good luck.